Okay, the last thing we're going to look at is solving trig equations that involve identities. Okay, so not only can we prove identities, but we can encounter equations that include them. So it's kind of the same thing that we talked about when proving identities. What you want to do is you want to get things either in terms of sine and cosine, or all sine, or all cosine. And the majority of these kind of questions, you're going to have to factor to solve. Which means that what you want to do once you get everything in terms of sine and cosine, you want to be able to move everything over to one side and have 0 on the other, because that's how we solve any equation by factor. So if we look at this first one, what's the first thing you think you'd do? Change tan x to sine x over cos x. And remember, we're not proving an identity here. We're not proving that this side equals this side. We're solving it. We're solving for x. Well, I've got a fraction equation. What do we do with fraction equations to get rid of the fractions? We multiply by the lowest common denominator. Well, there's only one denominator in this case. So on the left, cos x and cos x will take each other out. We'll be left with sine x on the left, and we'll be left with 2 sine x, and now it's also got a times cos x on the right. And remember what I said, let's bring everything over to one side. So I'm going to put the sine x over to the right-hand side by subtracting both sides by sine x. Because now I've put myself in a factoring situation. Now I know you guys are used to seeing squares when you're factoring, but not all of them, not all factoring equations are squared. Can you see any kind of factoring you can do here? Sorry? Take out sine x, it's a GCF. It's a GCF. And when you take out sine x, well, this divides sine x is 2 cos x, minus sine x divides sine x is 1. And remember how, after we factor them, how we solve? We set each of the factors equal to 0. So sine x equals 0. I'm going to put this one a little bit more here. 2 cos x minus 1 equals 0, which means if we add 1 and divide 2, cos x will equal a half. These are unit circle values, which means we can use our knowledge of the unit circle. And remember, if you look at, just to check above, radians. So where on the unit circle is the y coordinate 0? At what angles in radians is the y coordinate 0? 0. 2, and if it's 0, it's also 2 pi and pi. Good. Solving this one. Pi over 3. There is one more. 5 pi over 3. Excellent. And there's all your solutions. Okay. Just remember, oh, there we go. Sine 2x is an identity. Two sine x is not an identity. Make sure you don't get confused between the two. Okay. The 2 has to be in front of the x for it to be a double angle identity. Okay, well, we look at this one.
2 sine x cosine.
2 sine x cosine. Zero. Wow, it almost looks like identical to this one. Because when we factor, we can take out it's a GCF. When we factor, we can take out a sine x and be left with 2 cos x plus 1 equals 0. So almost identical. Well, sine x, and again, I'm looking in radians, equals 0. We solved that one in the previous. X is going to be 0, 2 pi and pi. Cos x plus 1 equals 0. This time cos x is going to be negative a half, not positive a half, which means those will be pi over 3s. But because it's negative, it's in quadrants 2 and 3. So that would be 2 pi over 3. And 4 pi over 3. Okay. This next one, well, there's no double angle identities because there's no 2 theta, but it's different than what we're normally used to because we're normally used to seeing all sine or all cosine, right? And then we can factor those. But we don't know how to factor when we've got a sine squared and cosine middle. Is there anything we can change to make it all sine or all cosine? Can you write that in terms of sine or cosine? 1 minus cos squared theta. Remember, that's the sine squared plus cos squared equals 1 variation. Plus 5 cos theta plus 1. Now I got everything in terms of cosine. But I got to simplify this before I start to factor it. So I got to get rid of the parentheses. Two plus 1 makes 3. What's a bit of a problem here? Before I start to factor. Yeah, that negative, because we normally see positive, right? Well, that's easy. Let's divide anything by -1. And it becomes positive 2 cos squared theta, but then all the other terms change sign. Minus 5 cos theta minus 3 and minus 0 is just no 0. Now we are ready back. And remember, you want to make it easier on yourself, temporarily take out the cos theta and replace it with x, because maybe that might be easier for you to see. That's one of those ax squared trinomials where we can't do the sum of the middle is this and the product is this because there's a number here besides 1. So we got to do kind of the guess and check, then the outside inside thing. What do the first two terms have to be? Has to be 2x to make this when I multiply. These two numbers have to be negative, or 3 and 1, one of them being negative to make this when I multiply. Anyone want to try? 3 and 1. Can't hear. Somebody give me something to try.
Give me something you said.
I have no idea what you just said.
3, 1.
One has to be positive, one has to be negative. 1 and negative 6. They have to multiply to get 3.
Negative 1 and positive 3. Plus 5. Only 1 there. Well, I don't know. Easy number. Negative 1, positive 3.
Negative 1 and negative 3. They have to multiply to get negative 3. Okay. Thank you. That's going to give me positive 6x and negative x. Negative 3, positive 1. Well, wait. You mean just change the signs here? Good. There we go. And now, instead of x, I'm going to replace it back with cos theta. So I get 2 cos theta plus 1 equals 0. Cos theta minus 3 equals 0. So cos theta equals negative a half. Cos theta equals 3. Anybody see anything with this one? Remember, cos theta and sine theta can never be higher than 1 or lower than negative 1. No solution. I mean, and then you can go ahead and try it, do the quadrants thing, and then find the reference angle by doing cos inverse 3, you'll get an error. Okay? How about this one? Cos theta equals negative a half. It is? So what would that be?
2.
We want to make sure that we read the question, right? Because it's in degrees. Make sure. It's easy to miss. Make sure. So 2 pi over 3, which is up here, is 120 degrees. And then down here, 4 pi over 3 is 240 degrees. Just throwing those in once in a while, because you just never know. Okay. This one. We have a double angle. We also have a sine t. You can change cosine 2t into 3 possible equivalent expressions, right? Which one should you choose? The one with just sine in it, exactly. Which is what? 1 minus 2. That?
1 minus 2 sine squared.
Equals sine t. Now we've got to factor in 1. Let's bring everything over to the right, because then it's going to make this negative 2 sine squared t positive. So 0 equals, when I pull this over, it becomes positive. The sine t is already over there and it's positive. And when I pull the 1 over to the right, it becomes negative. And now I've got another one of these ax squared trinomials.
Watch these lessons in slow motion.
Again, no clue.
So I think I'm gonna have to watch these videos in slow motion.
You said it, I didn't. First 2 terms. Hello, hello, hello. Okay, here we go again. 2 numbers that multiplied in -1.
Why the -1?
You want to do that one? Positive 1, -1? Or can some of you see into the future? That if, remember,
I can see the future.
it's got to make positive x. So shouldn't this be positive when it's multiplied?
Wow.
You see? You see? You're gazing into the future.
I thought I just didn't want to say it.
Wait, you got shot.
I'm so glad you came this morning. So we've got 2 sine t minus 1 equals 0. And we've got sine t plus 1 equals 0. Therefore, sine t is going to be positive 1/2, and sine t is going to be 0. That is -1, that's it. Sine t is going to be -1. We are back in radians. Gotta watch how I write that sine t. What's t? Why can't we just what?
Yeah.
I suppose you could. I suppose you could just cross the question out and say, I choose to use theta.
So what is T?
I mean,
You just like put the back.
I wouldn't mark it. I wouldn't mark it
Okay. Good.
because you've done everything correctly
I'm confused.
and you haven't changed the question. You've just changed the variable you're going to use.
Question.
I-
What's the difference between T and theta?
One is an Arabic-based letter and the other is a Greek-based letter.
So why would you switch it?
Because sometimes we don't use X all the time. Sometimes we don't use theta all the time. Sometimes we use other letters.
So it means the same thing?
It's an unknown.
Oh.
Somebody give me this. Thank you.
Why didn't you just switch theta? Why are you trying to confuse us?
And this one? Excellent.
Can we just use theta?
She just said you could. When I was asked.
Someone like trying to confuse us all of a sudden.
Because sometimes it gets mixed up. You know? Heaven forbid I'm trying to help you. Last one.
What's theta?
Yeah, go back to theta. Everybody can, you know, kind of. It's a double angle. Does it really matter which one I choose? So I'm going to choose the one where it's positive. Isn't this also 2 cos squared theta minus 1? I could have done the 1 minus 2 sine squared theta, but then I'd have to deal with -2 sine squared theta, and I don't want to deal with that. This is not a fact, well, this is not, yeah, this is not a factoring one, because it's not a difference of squares. You can't, it's not a trinomial, okay? You can't GCF it. Best you can do is get cos squared by itself. So with this one, you've got to move the 1 over, so it becomes +1. Divide both sides by 2. And you get that. How do I get cos theta now? Anybody want to add to that? Plus minus square root.
Question is maybe stupid, so why do you have to put plus minus?
Because like we learned that in grade 11,
Oh,
okay? Because like the square root of 64, if I say x squared equals 64, x could be +8, could be -8.
oh, okay.
So I've got cos theta equals square root of 1/2. Cos theta equals negative square root of 1/2. Now this is, ooh, it looks really close to a unit circle value. But that square root is all wrong. You remember how we can make it a unit circle value? We did one like this when we first started solving.
We got this. Give me a second.
You won't find it there. Remember, square root of 1 over 2 means the square root of 1 over the square root of 2. So I could write it like this. That means the same thing.
Oh, I was thinking that.
Rationalize the denominator, turn it into a non-radical by multiplying the bottom and top by √2, and I get √2 over 2. That's a unit circle value. So this is kind of a special case question. Just remember, if you can remember, if you get square root of 1/2, remember it's √2 over 2. You don't have to show your work. And so this one would be cos theta equals negative √2 over 2. And I got to solve each one. We are in radians. Positive √2 over 2, and it's cos. Pi over 4. Yeah, the one up there and the one down there. Not 5 pi over 4, 7 pi over 4. And then negative √2 over 2 would be the other pi over 4s. The 3 pi over 4 and the 5 pi over 4. Yes? Thank you. Notice this notation up top. Theta is everything. As soon as it's everything, we're all. We've got to add that notation to complete it.
Top secret. I just feel like that's a lot, right? 2, it's kind of weird.
Why heard is this? Okay.